Let floor x denote the largest whole number that is less than or equal to x. For example, floor of negative pi is -4. A function f of x is defined as follows. If 0 less than x less than 2, then f of x is equal to 3 over 4 to the power of the floor base 2 log of x. And f of x equals 0 otherwise. Note that, for example, f of a half is equal to 4 over 3. Makes sense. If x is equal to a half, log 2 base of a half is -1. 3 to the 4 to the -1 is 4 over 3. Find the value of this integral. Okay, I have seen questions similar to this in the past on this channel and done them. I mean, it's just sort of a question of keeping track of how things work. So the integral from 0 to 2 of f of x dx, it's 0 for other values of x, but we're only integrating from 0 to 2 anyway. So the idea is probably want to write this as a sum of some sort. Maybe first start by doing a change of variables. Let u equal log base 2 of x, something like that. So then du is equal to 1 over x log of 2, natural log, of course. Right, hold on. U is equal to log x over log 2. So du is equal, and I'm missing a dx. 1 over log 2, 1 over x dx. Okay. Then the integral becomes integral when x is 0, u is -infinity. When x is 2, u is equal to 1. And I have then 3 over 4 to the floor of u du. And I also might try to write this in a well, I want to think about this backwards in some way, I guess. This is certainly going to be a sum. Okay, when u is between 0 and 1. Oh, hold on. Hold on. I forgot about, so dx is maybe this isn't the best way to do it. Can't believe I did the substitution wrong. So this becomes 2 to the u log 2 out in front times du. Seems a lot messier to actually work with. Although maybe we can do it, just break it up into a sum. Well, sum will go from k to k plus 1. 3 over 4. So when I'm between k and k plus 1, this floor of u is just k. This is still just 2 to the u du. And k goes from negative infinity to 0. I mean, this is not a standard way of writing this. Let's write it as 0 to, oh, man. We're going, I'll just write it like this. I mean, let's write it properly. Let's write it properly. So the integral is going to go from I need this to count downward. So k goes from 0 to infinity. Now we have 3 over 4 to the power of negative k, but this is the same. I've reversed the order of the sum, but I haven't done anything inside the integral. Right, so I'm still integrating over the same regions in the same direction. We're going from some number to a higher number, so this doesn't change direction. Yeah, it's a little bit odd to write a sum with indices that go in the wrong direction. But this, hopefully you know what I was trying to get across here, but this is what we're actually going to work with. Okay, so this is log base 2. It's funny, there's been a lot of conversation on my channel recently about how much you should be using the multiple choice answers to figure out the answer to the question. I like to just work out the whole thing. I don't like to look at the multiple choice answers, except to basically check whether I'm correct. But I looked at the answers just now and I see that they're all positive integers, 1, 2, 3, 4, 5. So this simplification I expect to turn into something easy. Anyway, we have a sum. K goes from 0 to infinity. I expected it'll end up as some geometric series or something like that. And I'll take this thing outside of the integral. So I have integral negative k to negative k plus 1, 2 to the u du. This is a natural log of 2. Okay. 2 to the u is e to the is it u log 2? So this becomes e to the u log 2 divided by log 2, evaluated at negative k and negative k plus 1. So the log 2's simply disappear. And I get, and I guess e to the u log 2, that is 2 to the u. So this is 2 to the negative k plus 1 minus 2 to the negative k. That has a simplification, I'm sure. If I factor out 2 to the negative k, I get 2 minus 1. Okay. k equals 0 to infinity of, oops, where did you go? Sorry. 3 over 2 to negative k. So this is 2 over 3 to the k, and that's 1 over 1 minus 2 over 3, I hope. Three minus 2 over 3, which is 3. So that's option C. Okay, I hope I didn't make any arithmetic mistakes or anything like that. The fact that we end up with a whole number, which is one of the options given, gives me a little bit of reassurance, but there's a lot of places where I could have had an off by 1 index or something like that. I think the general approach here is fine. That substitution just kind of works. Like if you work directly in the x variable, then by dividing this, like by making this substitution, what it allows us to do is divide an integral into equally sized subintervals. But if you do that directly in the x variable, you got to figure out not when does x cross over an integer and the floor value changes, but when does log of x cross over an integer and change the floor value of that. So it's a little bit easier to work directly in this with this variable. Maybe there's like another clever way of changing this into a series quicker, right? I don't actually get a pure series until here, or maybe the line above. I'm sort of fiddling around with integrals and summations and so on. And this weird notation was just, I guess, a placeholder for what I really meant. But, you know, it's fine. This is the real way to write it with like a proper sigma summation notation where the index is increasing. Anyway, I don't really have too much more to say about this one. It was a little bit fiddly, but I think this approach was fine. But let me know if you find a faster way to do this. I'd be interested to hear that. Thanks for watching.